Hello everyone, welcome back to our channel Problematical. We were discussing chapter 2 Polynomials, class 9th Maths NCERT, exercise 2.5. Now you were done with the first 4 questions of this exercise. We will continue with question 5. Question 5 says you have to factorize the two given polynomials. First one is, let's consider them a P of x, or let P of x is equals to 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now by observation, here you have something x square, something squares, 3 squares, and combinations of these variables. Observe the variables: x square, y square, z square, xy, yz, xz. So this looks like a plus b plus c whole square formula. Let's rewrite this: 2x whole square plus 3y whole square plus 4z whole square plus, I'm only taking 2 common, 2 times, you'll get 6xy minus 2 times 12yz minus 2 times 8xz. We know the formula for this. Since xyz variables are used, we'll write the formula in terms of ABC. A plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Now comparing these two formulas, we have your P of x can be written as 2x whole square plus 3y whole square plus 4z whole square. Now observe, plus, you need a plus sign over here, you've got a plus sign. 2 times 6xy, x means this term, y means this term. And 6 can be written as 2 into 3. So you can write 6xy as 2x into 3y. Next, here you have a minus sign and here you have a plus sign. So let's place minus sign inside the bracket. So if you place minus sign inside the bracket, it would look like something like this is plus and minus sign goes inside. Similarly, in the third term as well, I'm taking minus sign inside. Why am I taking it inside? Because in your formula, all signs are positive. So plus 2 times. Now yz. Now you've already established that y term is positive, 3y. So y term means this term, z means this term. Here you have minus 12. So 3 into 4 is 12 and 3 is positive. So 4 has to be negative. So let's rewrite this part. Minus 4z whole square, you'll again get the same 16z square. So this can be written as 3y into minus 4z. Again, here you have x and z. So minus 8 can be obtained by minus 4 multiplied by 2. This is 2x, 2 times 2x into minus 4z. Now, this P of x looks like the right-hand side of this given or known identity. Therefore, your P of x can be summarized as, or you can write the comparison value as well. Let's write the comparison value first. Comparing these two, we get a is equals to 2x, b is equals to 3y, and c is equals to minus 4z, which means your original P of x will be equals to 2x plus 3y minus 4z whole square. That's your final answer of P of x. The second value is will also use the same formula because you have 2x square plus y square plus 8z square minus something xy, something yz, something xz. That's all that. So your second part is 2x square P of x, right? Let P of x is equals to 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8xz. Now this can be written as root 2x whole square plus y square plus 2 root 2 z whole square. So you're writing these in whole square terms. Here you need a positive sign in all the three terms. So minus is taken in the bracket. You're left with plus 2. This 2 goes outside. You're left with minus root 2 xy in the bracket. Again, plus 2 outside. You're left with 2 root 2 yz. Plus 2 outside, minus 4xz inside. Here, your again formula, you know the formula. X plus y plus z whole square is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. So your given p of x will become root 2x whole square plus y square plus 2 root 2 z whole square plus 2 times. Now here you have xy, here you have x into y. Since this is negative, either of the two terms has to be negative. X term is root 2x. So this is root 2x multiplied by y. Now understand which term has positive value. In the bracket, your second term has positive value, which means y and z both are positive. This one and this one both are positive, which means this one has to be negative, right? The second explanation would be y and z both are negative. But if y and z both are negative and x is positive, in that case, your z has to be negative according to the third scenario, which again doesn't fit the criteria. So your x term has to be negative. This means the next can be written as positive of yz. Y is solo and 2 root 2 goes with z. Plus 2 times. We know that the negative term is x. So with x, let's write the negative term minus root 2x. And z term is 2 root 2 z. Now if you multiply these two, you have minus root 2 x into 2 root 2 z. This will be minus root 2 into root 2 is 2 multiplied by this 2 xz, which is minus 4xz. That's why we were directly able to write minus 4 in terms of minus root 2 into 2 root 2. So comparing this with your given equation or identity, not equation, identity, your p of x will become equals to first term, which is negative because root 2x is negative, which means here also you'll have to place a negative sign, will be minus root 2x plus y term is y plus 2 root 2 z. Now, in the identity, I've used XYZ. You can use ABC to avoid confusion. So this was the fifth question. Let's start with the sixth part. Sixth question. Write the following cubes in expanded form. To write the cubes of these values, you should know the formula for writing cubes. So there are two formulas for cubes. Since AB is used in the second question, X and Y are in the first and third. Let's go with capital values or P plus Q. So P plus Q whole square whole cube is equals to P cube plus 3P square y P square Q plus 3PQ square plus Q cube. P minus Q whole cube is equals to P cube minus 3P square Q plus 3pq square minus qq. Now all you have to do is compare your LHS with the given expression or combination of factors and put it in the formula. So in the first part, 2x plus 1 whole cube can be written as 2x whole cube plus 3 times 2x whole square into 1 plus 3 times 2x into 1 square plus 1 whole cube. All you're doing is placing this value as p and this value as q in this formula. Solving this, you have 8x cubed plus 3 times 4x square plus 6x plus 1. So this is 8x cubed plus 12x square plus 6x plus 1. Second, 2a minus 3b whole cube. Now this looks something like the second formula because you have a minus term between the two terms. So this can be written as first term whole 2a. First term whole square whole cube. Yeah, first term whole cube plus 3 times 2a whole square into 3b plus 3 times, there should be a negative sign. Yeah, 3 times 2a into 3b whole square minus 3b whole cube. This is equals to 8a cube minus 3 into 4 is 12a square into 3b plus 3 2s are 6, 6 3s are, 2 3s are 6, 6 3s are 18, ab square. Sorry about the brain freeze there. 8a cube minus 36a square b plus 18ab square minus 27b cube. Next. Third question states 3 by 2 into x plus 1 whole cube. So putting it into the formula, we get 3 by 2x whole cube, which is a cube plus 3 times a value whole square into b value plus 3 times a value as it is into b value whole square plus b value whole cube, which is 27 upon 8 x cube. 3 square 9, 9 into 3 again 27, 2 square 4 x square plus 9x upon 2 plus 1. Now you need not solve this like take the LCM of the denominator and balance it out beyond this. Both x minus 2 upon 3 into y whole cube. So a minus b whole cube formula will be applied over here. You will get x cube minus 3 times first term square into second term plus 3 times first term as it is into second term whole square minus 2y upon 3 whole cube. So second term whole cube, which is x cube. Here 3 will get cancelled with 3. Here also 3 gets cancelled with 3. Minus 2x square y plus 2xy square. Sorry, 4xy square because 2 square is 4 minus 8y cube upon 27. Okay. Is there something wrong? Yeah, this is 3 square. So you should get a 3 in the denominator. Because when I applied square, I applied it in the numerator, forgot to apply it in the denominator. So that's your sixth question. Let's go with the seventh one. Evaluate the following using suitable identities. Like a problem we did earlier in the last class, here also you'll have to apply the identities, but here you'll have to apply the identities for cubes. So a plus b whole cube and a minus b whole cube. These are the formulas that we'll use. I'm not rewriting it, so you can take it from here. First part, 99 can be written as 100 minus 1. And you're taking the cube of it. So it is a minus b whole cube, which is a cube minus 3 a square b plus 3 ab square minus b cube. Which is 3 times means there are 2 zeros, there should be now 6 zeros, minus 3 times 1000, so 10,000, so 30,000 plus 300 minus 1. So this will be equals to 100, it's 300, so 3 will be placed over here, 0, 300, you're adding these two, minus these two will again be added, 3 zeros and then a 1. Solving this, you will get 970,299. I'm leaving the calculation to you because this is like a simple subtraction. 102 whole cube will be equals to 100 minus 2 whole cube. This again will be equals to 100 cube minus 3 times 100 square into 2 plus 3 times, sorry, this should be plus because 100 into is 100 plus 2. So there will be positive sign. 100 into 2 square plus 2 cube. This is 100,000,000 3 times plus 3 into 2 is 6. So it is 60,000 plus 8 into 3, 2,400 plus 2 cube is 8. All you have to do is add and you'll end up with 1061208. Let me just 1 second recheck over here. Four threes are 12. Yeah, right. Third. 998 whole cube. So this will be equals to 1000 minus 2 whole cube. A minus b whole cube, which is a cube minus a square b plus a 3 times b square minus b cube. This is equals to 1. 3 times 0 thrice, which is 9 zeros, minus 3 into 2 6, 6 followed by 3 times 2, which is 6 followed by 6 zeros, 1 2 3 1 2 3 plus 2 squared 4, 4 into 3 is 1200 minus 8. So minus 8 will be added with this, 1200 will be added with this, calculated, you will end up like a big term, 9940119992. Exam you will have to calculate it yourself, so make sure your calculation is fast enough. Factorize each of the following. It goes without saying that you will have to make use of the identities that are taught rather than directly doing it. So your first part is 8 a cube plus b cube plus 12a square b plus 6ab square. This looks something like a plus b whole cube. So your 8a cube can be written as 2a whole cube. One second. This can be written as 2a whole cube. B cube can be written as b cube. 12a square b. So you should have 3 common. You're left with 4a square b. 4a can be written as 2a whole square into b plus, here also you take 3 common because it fits your formula, 2a b square. So 2a into b square. So this is a plus b whole cube. You have to factorize. That means you have to write the final answer in terms of factors. Factors always have a linear polynomials with power 1. So 8a cube minus b cube minus 12a square b plus 6ab square. We can write the same thing over here. All you should know is here the sign is negative, b square is negative, which means your second and your fourth term are negatives, which means your answer you'll end up with 2a minus b whole cube. Now, why didn't we write b minus 2a whole cube? So b cube is negative, hence b is the second value. 8a cube is positive, hence it is the 2a is the first value. Third, 27 minus 125 a cube minus 135 a plus 225 a square. Let's rearrange it in the proper fashion. This is a cube, but you have a negative sign here. So let's write it in the fourth position. If this is in the fourth position, you should have another a cube, another cube. You do not have it, and a's power should be increasing from right to left, which is minus 125 a cube plus 225 a square minus 135 a. So your first value by default becomes 27. This should be equals to 3 cube, and your last term is equals to minus of 5a whole cube. Means this here is negative, second term is positive. Here you have a. That means here you should have 3 into, this is 135. Now 5 plus 3 is 8 plus 1 is 9. So by default 135 is divisible by 3. Let's divide it by 3. If you divide 135 by 3, what do you get? 3 to 4 is 12, 1 carry, 1 5 15, 3 5s are 15. Which means you can write 3 multiplied by which value? 3 multiplied by 45. Now 45 should have your 3 square, which is 9, multiplied by 5a. A is already present, so 5. This can be written as 3 square into 5a. Here also 3 is common. 5 plus 2, 7, 7 plus 2, 9, which means this is divisible by 3. If you divide 225 by 3, what do you get? You'll end up with 7s are 21 and 5, so 75. This is a square, so you should have 5a whole square, which is 25a square. You should have something like this multiplied by 3, and 75 can be represented as 3 into 25. So this is 3 into 3, which is your first term, into 5a whole square. So this can be written as first term minus 5a last term whole cube. Fourth, 64a cube minus 27b cube minus 144a square b plus 108ab square. So clearly this is your first term, second term, third term, and fourth term. So first term, now you will have to show this breakage. If asked in a competitive examination, you can do it in rough, but in fair, this breakage is supposed to be written. Now, let's do it on the next page. (64a cube minus 27b cube minus 144a square b plus 108ab square. This is equals to 64a cube means 64 is 4 cube. So 4a whole cube minus 27b cube is 3b whole cube. So this is your first term and your last term. We know that the answer that you'll end up with is 4a minus 3b whole cube. I mean, this is an assumption. This is the most likely possibility. Let's see if that is in fact the answer. So minus 144a square b. This should be your second term because first term is 4a whole cube. So you should have an a square term over here. Minus 3 times 144. If you take 3 out of it, which is 144 divided by 3, you should get 4 into 3 is 12, which is 3 over here. 2 is left behind. 2 into 4, which is 8. Now, 38. Again, I'm making too many mistakes over here. So 3 4s are 12, 2 4, 24, 8s are 24, 48. 3 into 48. You need 4a whole square, which means there should be a 16 term over here. Let it, you get 16 into what is 48? 16 into 3 is 48. So 16 is 4a whole square into 3. Next, plus 108a b square. Dividing it by 3, you get 36. Now 36 can be written as 4 into 9. 4a into 9b square means 3b whole square. Therefore, by this observation, we can easily say that this is equals to 4a minus 3b whole cube. Next, fifth part. 7b cube minus 1 upon 216 minus 9 upon 2b square plus 1 upon 4b. Here you have 7 into p cube. Now, 7 into p cube means, what does this mean? And 1 upon 126. Let me recheck the question. It should be 27. Yeah, it is 27. 27p cube. So this is 3p whole cube minus 216. 216, it is which cube? 6 cube. So 1 upon 6 whole cube. Minus 9 upon 2p square. So this can be written as 3 into 3 upon 2p square. Plus, if you take 3 common over here, you're left with p upon 12. 3p whole cube minus 1 upon 6 whole cube. Now here you have p square, which means you should have 3p whole square minus 3 upon 2 into 3 upon 3 p square. You're adjusting it. Plus 3 into p upon 12. Here also, we know that at least one term is going to be 3p. So, to have 3, you multiply by 3, divide by 3. This is equals to 3p whole cube minus 1 upon 6 whole cube minus 3 into Here, this complete term in the numerator part will be equal to 3p whole square. 3p whole square into 1 upon 6 plus 3 into, you have to have a 3p term, we'll take this 3p term. Then you're left with 1 upon 12 into 3, 36. So this is 1 upon 6 whole square. This is a cube minus b cube minus 3a square b plus 3ab square, which is 3p minus 1 upon 6 whole cube. We'll stop here and yeah, all these values have to be written in factors. You cannot just leave it here. You will have to mention them in terms of factors. Okay, so we'll stop here and we'll continue the rest in the next class. Thank you.